Okay guys, in this video we're going to build on this idea of box and whisker plots and really take a look at how we can use them to compare different data sets, especially if these data sets don't have the same number of data values necessarily. So when we look at these compound box and whisker plots, which is kind of the emphasis of this video, really define this as two or more box and whisker plots along the same axis. And so excuse me, we're going to be looking at a similar set of data as we did in the last video, but it says here that the following set of data contains the resting heart rates of 13 randomly selected adults, also aged 20 to 40, who exercise 4 or more times per week. Now, note that this is people who say that they exercise 4 or more times per week, and so, I don't have any proof, but I do have their word on it. And in this case here, you'll notice that last time we had 13 data values, this time we have, 10 data values. This time we have 13 data values. So we're going to look at how this situation is a little bit different. So looking at this, it says find the 5-number summary and then graph both the box plots from this set of data and the last set of data on the same axis. And so that means that we're going to use what we just did in this last video here, this right here. And as a matter of fact, I'm going to cheat a little bit here. You know what? No, we'll remake the graph. We'll make the graph again. But ideally, I really could put this same data's box plot on this graph right here, and we could compare them. But I want to go from scratch, so we're going to do that. But taking a look at this data set here, at least this time, I already put the data set in order. I figured to facilitate things here. So let's go ahead and start with our 5-number summary, these 5 numbers that we have to plot in the first place. Starting with your min and your max, you just throw a box around those. But we are also going to find our median next. And so keep in mind, we have 13 data values. Cool thing about having an odd number of data values is that we should land on one particular data value here. And so if I count in, like I count in, from here I go in like 1, 2, 3, 4, 5. And from here I go in from 58, 1, 2, 3, 4. Let's see, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. That means we're going to land on this 67 here. And so I'm gonna label these. As a matter of fact, I'm going to say min, max. We're going to write median. Guess what we're also going to write? Q2, because it is the end of our second quarter of data. Now here comes the fun part. We have to split the halves in half. Now here was the rule. Remember that whatever box, wherever your median box is, that kind of represents an untouchable value. That means that when we talk about splitting the halves in half, this median is never included in the halves. So that means that when we put parentheses around the first half of data here, I always have my parenthesis falling within the median on either side, okay? And so now let's go back and look at splitting these halves in half. Now, I do want to point something out here, and that is that this first half of data, I count 6 data values. And so that means that when we find the median of this first half, we're going to land on these middle 2 data values here. And so you know the rules. If you land on 2, or even 1, you put a box around it. But 2, you put a box around them. You split it in half, and then what we're going to have to do is we're going to have to find the average of these 2 values here. And that's the rules. You always do this. So 61 plus 64 over 2, you know what, actually, I just want to have you get your calculator out and check this. And so we're going to say 61 plus, not times, plus 64, enter, divided by 2. We get 61 plus 64 is 125, and we'll take 125 divided by 2 is what I had meant to type in there. So 62 and a half, and I'm going to put this on top here. We say 62.5, and because I don't have a lot of room here, I'm just going to put in front of this Q1. And also on the right side here, we would land on these middle 2 data values when we count it. So 69 and 70 here. I'm also going to write 69 plus 70 over 2, but I don't think I should need a calculator to tell me this one here should be 69.5. And then I'll throw a box around this, and we'll put Q3 on top. So our 5-number summary we have here looks like our minimum is 58. Now I'm going to write BPM, and we're going to kind of take that idea all the way down the row here. But BPM, our max is 75. In terms of median, we were able to find 67 BPM. Q1 or quartile 1 was 62 and a half. Now that's interesting because that means that these data values that we're finding here, these statistics we're finding here, don't actually have to be our data values that were in the original data set, but they still provide us a good idea of how far our data spans. And then Q3, of course, looks like 69.5 beats per minute. So let's look at some things here. Creating our box and whisker plot first, we're actually going to create, and this is in our instructions up here, we're going to create or graph both of the box plots from the same, from this set of data and the last set of data on the same axes. And so I'm going to label this time down here, we're going to say resting heart rates we're going to say in BPM. So we always want to provide units here. But the same as I did last time, I feel like it would be sufficient to start down at, say, 50 and maybe go up to 100. You always just want to kind of give yourself some room. So 60, that means 70 is about right here. 80 is about right here. 90 is about right here. And then 100. And you notice I made those lines a little bit bigger. That's because I'm going to go back through and I'm going to put these little in-between notch marks. Now you don't have to do that. It's just one of these things that I just can't help myself. So here's our number line. Let's go ahead and start with our last set of data here. And so what I suppose I mean is these were the people that were randomly selected. Now, when I say randomly selected, they did not tell me whether or not, because I didn't ask them, they exercised 4 or more times per week. So it may be the case that there are exercisers that do the same thing that our current set of data does, okay, and our last data set. But generally speaking, this is a random selection of adults, whereas we controlled, or I controlled for exercise in this group of people. And so at least the hypothesis would be, at least me, that their heart rates would be lower, generally speaking, resting heart rates, just because their hearts are really trained and don't have to work as hard to pump blood as efficiently. But we're going to see that here once we get our 5-number summary plot on this same number line here. So because I'm going to start with this group of data, I do want to distinguish between them. And so we're going to give these people a name. We're going to say random group, and maybe we call it group A. Group A random. And so off on the side, it's often appropriate here, we're going to say group A. And maybe I write a little annotation here, is that this group was our random group here. And so with this random group, we're going to kind of put it off to the side of this, I guess, title. Now above this, we're going to put group B, I suppose, if we're going to keep with the method here. And this was the exercise group. Exercise. And so we could call this maybe our experimental group, whereas our first group is our control. We're going to put their box above it. And one thing that I didn't, kind of show here, and that I'll put a box around this just to show that I can do, is this. We could color code it as well. So group A, putting their data values on here, we had 64, 70, 72. So I'm going to go back and put this on here again. We had 60, 64, 70, 72. So 64 was here. Take that back. There we go in red. 64, 70, 72. We also had 75. And then I believe our max was 82 here. So 82, we're going to put a line or a dot over here on 82. So remember, the vertical bars go on here. We create our box first, and then you throw your whiskers on there. And you don't have to put numbers above these. It's sufficient that you have this up on the side. Now group B, we're going to look at its data values here, but its data values start with 58, and this is going to be in purple here. So 58, is down here, 58, 62 and a half. So we got to say halfway between 60 and 65. We're going to say 67 was next. 67 would lie, closer to 65 than 70. We also have 69 and a half, so just a shade below 70 here. And then we had our maximum data value at 75, so right here. And so again, remember, we're going to put our vertical lines around the middle 3 points first, create our box, and then our whiskers. And so instantly, some things that I do want to actually calculate are these: our range and IQR for the second data set before we get too far. Our range, recall, this is going to have to be 75 minus 58. And so 75 minus 58, I do want to check here. 75 minus 58. We get 17 beat per minute difference here. So this box spans 17 beat per minute from minimum to maximum. In terms of the IQR, this would be our 69.5 minus 62.5, and I feel confident that I can tell you that that's a 7 beat per minute span. And so when we compare these two data sets now, here's the thing about it. We can draw some conclusions, but using range and IQR and these other quartile markings as support, we can look at how these compare with one another. And so one thing that I instantly notice is just that the exercise group, their resting heart rate, which is generally to the left of the number line, or lower than the non-controlled for exercising group, the random group. And so I think that my hypothesis would generally be supported, but I would want to give evidence. So in terms of supporting my evidence that maybe my hypothesis is correct, I could say things like, hey, the group that was controlled for exercise at least 4 times a week, we can see that their resting heart rate was generally speaking lower than the resting heart rate of the random group. And you could say that the difference between the median values, maybe the median here in our first group was 72 beats per minute, and our median in our exercise group looks like was 67. And so you could say 5 beats per minute less in terms of the medians between these groups here. And then you could also see things like, you know, their span. We'd say they had generally the same amount of span. As a matter of fact, the range in the exercise group was 17 beats per minute, and the range in the random group was 18 beats per minute. And so you could see things like, you know, just because they exercise doesn't mean the range would be any different. It just maybe moves them down, which would support that exercise would promote lowering your resting heart rate, you know, promoting heart health because your heart doesn't have to work as hard. So again, just kind of drawing conclusions from these, you want to use these statistics to support yourself. But generally speaking, we can compare two graphs using their box plots, and that's what I want you to do for me today. Cheers.